Let's consider an example dealing with projectile motion. So we have a soccer goalkeeper, throws a soccer ball horizontally from the ball box to the player. The ball leaves the keeper's hands at a height of 2.1 meters and strikes the ground 5.6 meters away. We want to calculate the speed at which the keeper threw the ball. So the first thing I'm going to do is draw a diagram. So here's your keeper. Throw the ball at some initial velocity we don't know. The ball is going to start out 2.1 meters above the ground, and it's going to travel on a curved parabolic path and hit the ground over here 5.6 meters away. So now we need to organize what we know in projectile motion. We know that horizontal and vertical motions are separate. They are independent of each other. So we're going to list out what we know horizontally and keep that separate from what we know vertically. The thing we always know is accelerations. Nothing is acting on the ball in terms of a force horizontally, so then there's no horizontal acceleration. Vertically, though, the ball is in free fall motion, so then the acceleration is a negative 9.8 meters per second squared. We have here the two displacements. As the ball goes through its path, it will end up 2.1 meters below where it started. So delta y would be negative 2.1 meters and 5.6 meters to the side of where it started. So delta x is 5.6 meters. Now, additionally, we do know that the ball is thrown horizontally. If it's thrown horizontally, then it does have a horizontal initial velocity, and that's what we're trying to find. However, if it's thrown horizontally, the initial vertical velocity is going to be 0. Now, once we're to this point, we look at what we know, horizontally and vertically. I've got three things vertically that we know. That gives us enough to be able to use a motion equation. Now, the motion equation we can use is going to allow us to calculate the time. Time is neither horizontal or vertical because it's not a vector. And then we can use the time value over here with our horizontal numbers to calculate the initial velocity. So I'm going to start vertical numbers only. The motion equation we know enough to use would be delta y is equal to vi delta t plus 1/2 a delta t squared. So then plugging in our values, negative 2.1 meters. Vi is 0, so then 0 times delta t plus 1/2 times a negative 9.8 times delta t squared. 0 times delta t is going to be 0. Half of negative 9.8 is negative 4.9. We're going to divide that to the other side, so negative 2.1 divided by negative 4.9, and then we're going to take the square root to get delta t. So when we get our delta t value, we get a time of 0.65 seconds. Now we can pull that over and use that with our horizontal numbers to be able to calculate vi. So then horizontally, we know enough to use the same motion equation. So then plugging in values, my delta x, 5.6 meters. Vi is our unknown. Our time we just found, 0.65 seconds. 1/2 horizontal acceleration 0 times 0.65 seconds squared. 0 multiplied by anything is 0, so this last term is gone. And so I just take 5.6 divided by the 0.65, and we calculate the initial horizontal velocity to be 8.62 meters per second. So it's important in projectile motion. Diagrams can be helpful. Always list out your givens. Make sure you separate horizontal from vertical, and you keep those separate when you're plugging into the motion equations also. Ponder physics.